All right, grade 7, we have time for another flipped classroom lesson. Our topic is still thermal energy, and today we're going to talk about expansion and contraction. Remember our old friend, the particle theory? Talked about the particle theory a lot this year. Well, according to particle theory, a material's particles move faster and spread apart when the material is warmed up. It makes sense then if the material expands when the temperature increases and contracts when the temperature goes down. Let's click on these and see how the particle theory moves in a solid, liquid, and gas. So I'm going to start with solid ice. The molecules of a solid are jiggling in place. Not a lot of movement, stuck close together. How about in liquid water? Molecules in the liquid are flowing around. So as we can notice, there's more movement here than there is here. All right. How about water, vapor, gas? Lots of movement. The molecules in the gas are spaced farther apart. Before testing this idea, remember that a pure substance has only one kind of particle. On Earth, a pure substance can exist as a solid, liquid, or gas. These are the three states or phases of matter. In a solid state, the material holds its shape and size. If the temperature stays constant, the material cannot be compressed into a smaller space. But if we increase or decrease the temperature just enough, a solid material can expand or contract. We cannot always see these changes with our own eyes, but we can feel the effects. For example, if you want to open a tightly sealed jar, try running the lid under hot water. You cannot see it, but the lid expands just enough so you can twist it off. Here's another example. Engineers need to think about thermal expansion and contraction when building roads, sidewalks, and bridges. They have to make sure to include expansion joints in their construction to prevent roads or bridges from buckling or cracking when the temperature changes in the summer and in the winter. Liquid materials have definite size, but no final shape. It is a little easier to see liquids expand or contract. For example, look at the thermometer. When the thermometer rises, the thermometer liquid expands and takes up more space. When it is cold, the liquid appears to shrink. Because different liquids have different properties, some liquids expand or contract more quickly than others. Now let's see what it says here. Click on the arrow to see the thermometer liquid expand and contract as the temperature changes. All right, it's quite chilly out there today. Whee! It's boiling. Here's this winter. Freezing. Gases have no definite shape or size. Many gases are very difficult to observe because they cannot be seen. One way to see the expansion and contraction of gas is by filling a balloon and changing the temperature. If the temperature increases, the balloon expands. If the temperature goes down, the balloon contracts. Because the particles in the gas move quickly and are spread farther apart, it is much easier to see the expansion and contraction of gases than it is to see with solids. Move the blue box to see the animation. Well, I love animation, so here we go. Expanding and contracting balloons. Exciting. All right, we're going to finish today's flipped classroom lesson by having you think about something, and we will discuss it when you come to class. Can you give me an example of a solid expander? Can you give me an example of a solid contractor? Can you give me an example of a liquid expander? And now I want you to think about a liquid contracting. How about a gas expander or a gas contracting? We can use some of the examples we talked about in this flipped classroom lesson, or go online, Google yourself. Examples on a solid expanding or contracting, liquids expanding and contracting, or gas expanding and contracting. Looking forward to discussing this more next class. See you soon, grade 7. Bye-bye.